Hello everyone, myself Dr. Vipul M Patel from Dr. Subhash Technical Campus. So we are meeting again for the another lecture of manufacturing technology which is offered in 5th semester mechanical engineering. So in this lecture we are going to start or we will learn about the manufacturing technology chapter number 2, that is casting process, or in another language, if you want to divide it into the different two categories, then we can say that foundry technology and pattern practices. So first of all, in this lecture, different types of patterns, pattern materials, different allowances that we will complete in this lecture. So first of all, introduction about the casting process. So the casting is the founding process is the process of the forming objects by pouring the melted metal in the mold and letting it solidifies. So as we all know, I hope all of you have some idea regarding the casting process. So this is the process. In this it is also, we can say, it is one type of founding process. So in this process, if you want to make one job for workpiece with the use of this casting process, then first of all, which type of material we want. So that is called pouring metal or pouring molten metals in the mold. In which shape you want to, which type of shape you want to give to the particular workpiece. So that particular molten metal that we have to pour into the mold and letting it solidify. So after it cooled, then we will get the workpiece. Simply in this type of language we can say, right? So casting is one of the oldest manufacturing process dating back to more than 6,000 years. So after that, many innovative changes that we can see in this casting process, but this type of process we are using dating back we can say to more than 6,000 years, right? Many innovative ideas many scientists have implemented, and many changes we have already seen that. So this product this process that is known as a casting are used to extensively in the engines, machine tools and automobiles, aeroplanes, household appliances and many others. So in general life also we are using many types of these casting products. If in general language we can say gold rings, that also we are using some gold products as a earrings. And many of the gold items, many of the jobs that already we have used, that is also maybe produced with the use of this type of casting process. Many parts of the mechanical engineering, many automobile parts, many parts from the engine, then many tools, then many products of these aeroplanes, different appliances, etc. So in fact, we can say that all metals are at some stage of this production, and what materials are produced from which are cast in the ignite molds. So I hope you understand, and many of the students, you are from diploma engineering, so I hope you have different basics idea of this casting process, and these are the advantages and uses of this casting. So casting has certain characteristics, metallurgical, physical and economical advantages over the method of this metal processing. Why? Because if we are comparing it with this different manufacturing process on the basis of their structure of this metal, molten metal, mold, metallurgical, physical, economical, so we can see the advantages of this casting process on the basis of these different stages. So it is by far the cheapest method of this procedure, different shapes in metals or materials we can say. So those type of shape you want to give to the particular workpiece or job, on the basis of that you can prepare the mold you can prepare which type of material you want. On the basis of that, you can prepare the molten metal, pouring, basing, etc. So we can say that it is the cheapest method of the procedure of the different shapes of metals, right? So strength requirements permitting casting are cheaper than the weld melts and forging for the most applications. And casting do not exhibit directional properties shown by the metal working process, and the stance in all direction is same. So practically we can say all metals can be cast. So all metals, practically we can say those metal we can get solidified, it may use in the casting process simply. So types of casting. So casting may be divided into the 6 different classes, commercially known as a grey cast iron, alloy cast iron, steels, alloy steels, and non-ferrous casting. But most of the foundries specialize in 1 or 2 of these above types. It is rare that a foundry attempts all 6 types. So simple, those mag wheel, alloy wheel you are using in the automobile vehicle, that is also one of the most important example of the casting, right? So in most of the foundries specialize into the 1 or 2 of these above types, means cast iron, grey cast iron, alloy cast iron, steel, alloy steel, and non-ferrous casting. So that can attend only 1 or 2, and it is very rare that the foundry attempts all 6 types, right? So these steps involved in the making casting in sand molds. So these are the different steps that involved in the making of the casting in sand molds are: first of all, making the pattern and core box. After that, making the mold and core at suitable sand. Then third one, that is melting and pouring the metal. After that, you have to clean the casting. After that, inspect it, or inspection and testing of the casting. And after that, final one, that is reclaiming sand, and if you want to reuse for the mass productions. These are the different steps that can you have to follow the steps to making the casting and sand molds, right? So what is the pattern? First of all, we are discussing about the pattern. The pattern is solid. It is one type of a solid form that is used to make the mold. So even though a pattern generally reassembles the casting being produced, it differs from the casting in terms of the certain allowances that are required for the producing the current shape and dimensions, and in eliminating some minor details which are too complicated or small to be produced by casting and are left to be produced later by machining. And a pattern has to be designed to facilitate the molding and ensure good quality of the casting. The quality of the casting produced depends on the design of the pattern and its material and the construction. So a poor casting may result from the good pattern due to the various other factors, but a poor pattern would never make a good casting. So the importance of pattern in the casting is much, and the design of the pattern depends upon the shape and the complexity of the casting. So what is the importance of the pattern in the casting process, that you can easily understand with the use of this slide. And even though we can say that the pattern generally reassembles the casting being produced, in differs in the casting terms of certain allowances that are required to be produced in current shape and dimensions. If you want to eliminating some minor details which are too complicated or small to be produced by casting and are left to be produced later by machining, that is pattern. Now different types of pattern. So depending upon the design, pattern can be classified into the number of categories that is listed over here in this slide. So from the next slide we will discuss about the details of these different types of pattern, what is loose pattern, what is gated pattern. But first of all, remember it, all these different types of patterns: loose patterns, gated patterns, match plate patterns, cope and track patterns, pattern devices, cell patterns, built up patterns, and legged up patterns. So these are the different types of patterns we are using in the casting process. So first of all, we are going to start loose pattern. So loose patterns are patterns which are not connected to the other patterns or mounted on a plate. And we can say that the loose pattern also further we can classify into the three different categories, that is solid or single piece pattern, second one that is a split patterns, and third one that is a loose pipe patterns. What is solid or single piece pattern that you can see in this slide? Only one piece or a single pattern is most inexpensive of the all types of patterns. This type of patterns is used only in cases where the job is very simple and does not create any withdrawal problems. It is also used for application in the very small scale productions. It is single or solid piece pattern. Second one that is split, or in another language it also we can say two piece patterns. So with the use of this figure, I hope you understand split or two pieces patterns is most widely used type of patterns for intricate casting, and it is split along the parting surface, and the two halves of the pattern must be aligned properly by making use of the dowel pins. So you can see piece number 1 and piece number 2 in this figure. First figure is part to be cast, which type of part you want to produce with the use of this casting process, and after that how you will get the two pieces of this one pattern, pieces number 1 and pieces number 2, that is called split or two pieces patterns. So in this figure I have given the example of the dumbbells. So only dumbbells I want to produce with the use of the casting process, and how we will get this particular product into two pieces, that is pieces number 1 and pieces number 2, that is split or two pieces pattern. Third one that is a loose piece pattern. So over here you can see the figure. In some cases the casting may have a small projections of the overhanging portions. So the projections make it difficult to withdraw the pattern from the mold. Therefore these projections are made as loose pieces. So over here you can see the loose pieces. So we can take the advantage of this casting process. In some case casting may have a small projections, right? So this type of projections or overhanging the portions, and these projections make it difficult to withdraw. उसको अब निकालना चाहते हैं मोल्ड में से, तो इट इज वेरी डिफिकल्ट के एवी रीते तरत ज નીકળી શકે, એમાં થોડું આપણને પ્રોબ્લેમ થાય. So therefore this projection are made as a loose pieces. So this is a loose pieces. This is a casting. This is a split pattern with the loose pieces. This one is over here. This one is our product to be cast, and this is the loose pieces, and with the use of that we can easily withdraw the particular pattern from the mold. This is a molding box with a cavity. After main pattern has been lifted, loose pieces left behind, and mold cavity after loose pieces removed, right? So this is a loose piece pattern. Now this is a gated patterns. Gated patterns are number of the loose patterns connected with the gating system, and they are molded like a single pattern with the withdrawal from the mold in one pieces, thus reducing the molding time. And gated patterns are also useful when a number of small casting are to be produced. So more than one pieces if you want to made with the use of this casting process, then this type of patterns we are using, it is also called a gated patterns. So if number of loose patterns connected with this one gating system, and they are molded like a single pattern, right? So this one is a pattern, this one is a gate, and this one is a runner, right? This is called gated patterns. Now match plate patterns. So I hope with the use of this figure you can easily understand. This figure you can see that is a top view of this particular molding metals, and casting to be produced with type of workpiece you want to produce this casting process. It is called match plate patterns, and patterns are made into two pieces. One piece is mounted on one side and the other on the other side of the plate. It is called match plate. So plate may carry one or group of the patterns mounted on the match plates, and along with the patterns gate and runners are also attached, so produces accurate casting in faster rates. So which one is a plate? This one is a plate, this one is a pattern, this both are the runners. This is a front view of these patterns and this is the top view of these patterns. So this one is a plate, this one is a pattern, and this one is a runner. So it is called match plate patterns. Now cop and drag patterns. This one is a very most important question to be asked in your examinations. It may ask like that. List out the different types of patterns and list out the different types of patterns and explain cop and drag. Like it may ask, and many times it has been already asked in the GTU examination also. So this question is very most important question to be asked in your exam. So what is cop and drag patterns? I hope with the use of this figure you can easily understand. When very large casting are to be made and the complete pattern becomes too heavy to be handled in a single operator. अगर हम एक ऐसा पार्ट बनाना चाहते हैं जो इजीली सिंगल ऑपरेटर हैंडल नहीं कर सकता, मीन्स our workpiece or job that we want to make with the use of this casting process that can't possible to handle by the one operator, then such a pattern is made into the two parts. in एक अथवा तो बे पार्ट में डिवाइड करवी, इसे हम एक और दो पार्ट में डिवाइड करके प्रोड्यूस करते हैं और उसे जॉइंट करते हैं. So such a pattern is made into the two parts which are separately molded in the different molding box, and after the completion of this mold, the two boxes are assembled to form the completely cavity of the which one part is contained by the drag. Another is cop. So this one is a cop side and this one is a drag side. So thus in the way it is nothing but a two pieces of the split pattern, or which both the pieces are molded separately instead of the being molded in assembled position. So this is cop and drag patterns. This is a cell pattern. So why it is called cell? Because the pattern which has yellow hole in it. Only the outer shape is used for the making the mold and the core is prepared in the surface of the pattern. That's why it is called cell patterns, nothing else. Then built up and lugged up patterns. Built up patterns, why it is called built up? Because some intricate patterns with shape that cannot be easily made in one pieces are built up by the joining segments of the wooden strip, and the segments are made cutting strip of the wood to the curvature required. Then the segments are glued or joined together to form the desired shape and size. ऐसी हम जॉब बनाना चाहते हैं जिसमें हम उसको पर्टिकुलर विथ शेप कैन नॉट बी इजीली मेड, उसे हम इजीली नहीं बना सकते हैं, तब हम उसको बाय जॉइनिंग द सेगमेंट ऑफ द वुडन स्ट्रिप, वहाँ पे हम वुडन स्ट्रिप का यूज करते हैं, और द सेगमेंट्स आर मे बी कटिंग स्ट्रिप्स ऑफ द वुड टू द curvature shape if we require. Then the segments are glued. We have to fix it with the glue and join together from the desired size of the pattern. This is built up patterns. And lugged up means the patterns for the cylinder pipes columns are built up by the using the lugs or staves. Right? Now pattern materials. So any material to be used for the pattern making should have the following properties. जो भी मटेरियल आप पैटर्न्स के लिए यूज करते हो उसमें हमें ये प्रॉपर्टीज होनी चाहिए, दिखनी चाहिए. It should be then and then we can use it as a patterned material. Easy to work, shape and join. It should be strong, hard and durable so as to be resistant of the wear. It should be light in weight also. It should be dimensionally stable also. It should be cheap and easily available in the market also. It should be resistant to the corrosion and the chemical action, and it is able to take a good finish or surface finish, we can say. So these are the requirements of the properties for this patent material, we can say, right? And then factors to be consideration for the selection of the patent material. So number of casting to be produced, shape, complexity and size of the casting, degree of accuracy and surface finish required, design of the casting and casting method to be used. So how can we select the patent material? So these are the factors that we have to keep in our mind at the time we are selecting the patent material. So these are the different factors, important factors that we have to consider for the selection of the patent material. Number of casting to be produced, shape, complexity and size of the casting, degree and accuracy of the surface finish required, design of the casting and casting method to be used. So today is enough. In the next lecture we will discuss about the different patent materials, and thank you all.